Hey guys, today we're going to be graphing the note C4 as a sine equation. And out of this are a few steps we have to find first. The first step that we have to find is the frequency. And now the frequency of this note is 261.63 hertz. And to find this number, it is the amount of times that the sound wave repeats within a second. The second thing we have to find is the amplitude. And the amplitude of the note can vary depending on the graph. But for this one, we're just using 1, as it represents the loudness of the sound. The third thing we have to find is the wave equation, which follows the same format as a regular sine equation. And now this equation will be time as y equals the amplitude times the sine of 2 pi times the frequency times time plus the phase shift. And now we're going to explain what every part is. So A is equal to amplitude, F is equal to frequency, time is going to be equal to t, and this little theta we have in the corner is equal to the phase shift of the equation, but there won't be a phase shift in this specific one. The next thing that we're going to do is we're going to graph the equation specifically for the note C4. And so now we found all the individual parts of our equation. We know our frequency, our amplitude. We know we don't have a phase shift. We can graph it. So time equals sine of 2 pi, which stays the same, times 261.63, which is the frequency, times time again. And since the amplitude is 1, sine just stays as 1 sine. And so now we're going to graph it. Give me 1 second with me while I write this. So first we have to draw our little lines, make sure they're all straight. And the next thing that we're going to do is we're going to write the range of the function, which for this we're using a sound loudness of -1 to 1, so our range will be -1 to 1 in brackets. And our domain will be 0 seconds to 0.05 seconds. And now what we're going to do is we're actually going to graph the lines and see how they follow. So as you can see, they make almost like a ripple effect, and they go up from 0, up to 1, and then down to -1 at the first point in our graph. And so this matches the actual graph of a sine graph. As you can see, it starts at 0, goes up, comes down. It has all the same peaks and the same lows that a sine graph would have. And so guys, this is how you graph the note C4. Try it out for yourself.